All right, so we are moving into talking about sampling distributions and sampling proportions. So we're kind of putting everything together as far as z-scores, finding probability, mapping it on our normal distribution chart. And so here's a couple of things that we need to know before we get started. As we take a sample proportion, just like we did the bead experiment, and we tried to see like what was the range of proportions of the orange beads to the total number of beads. When we do that, we're stating that the mean of the sampling distribution here is equal to the population proportion. So when we said that we think there's about, I forgot what we even said, 10% of orange beads in the bin, then my samples should match or should be very close to matching that population proportion as I draw those samples out. So notice that our mean of our sampling distribution is equal to the population proportion, right? Standard deviation here, the standard deviation of a sample proportion depends on both our sample size and our population proportion. So this is standard deviation of our sample proportion is this equal to the square root of our population proportion times 1 minus our population proportion. So remember our success probability times our failure probability divided by the sample size there. And then we kind of talked about this, a condition that ensures the sample size is large enough for a normal distribution. So this ensures that when we take a sample, when we meet these conditions, that we have an unbiased sample. So we can get an actual good count of what we're doing. All right, so let's try this. We have an example. Suppose that 84% of students at a large high school regularly use a backpack to carry their books from class to class. Imagine taking a simple random sample of 100 students and calculating p hat, the proportion of students in the sample who regularly use a backpack. So two important things here, 84% and our 100. Now, this 84% tells us what our population proportion is. I'm not going to write it as 84%. I'm going to write it as a proportion, 0.84. Right? And then N represents our sample size. So let's population proportion. And N represents sample size. So notice it was a large high school, so it doesn't tell us how many there were, but there are probably close to 3,000, just like Martin. They're doing a sample of 100 students. So that's our N value. We want to identify the mean of the sampling distribution. So as I take a sample of these students, my assumption is that the mean is going to be equal to the population proportion. So the average will also be 84%. So the mean is going to be 0.84, right? So 84% of the students or 84% of this 100 students are going to be carrying a backpack. So out of the 100 students, my assumption is that 84 of them will have a backpack, right? Calculate and interpret the standard deviation of the sampling distribution. So let's do this by following our formula up at the top. So I'm going to do the square root of P, which is my population proportion, 84. Times 1 minus P, which is 0.84. So probability of having a backpack times the probability of not having a backpack divided by my sample size, which is 100. We can put this in our calculator here. So we have, go ahead and put all my things in here, 0.84 times 1 minus 0.84. You can always put 0.16 there. If you already know it in your head, divided by 100, and it's 0.036. We'll put 0.037. So this is the distance from the sample mean. Average distance from the sample mean. So that tells us our standard deviation of the sampling distribution. So let's describe the shape of this distribution by checking the large counts condition. So two conditions that need to be met. Your sample size times your population proportion has to be greater than or equal to 10. So our sample size was 100 and our population proportion was 84. This needs to be greater than or equal to 10. Let's calculate this. And it's 84. So 84 is greater than or equal to 10. So this one matches. So that means that's good. We want it to be accurate. And then the other part is that our sample size times 1 minus 0.84 has to also be greater than or equal to 10. So I'm just going to do 100 times that 0.16, which we know is already going to be 16. So 16 is greater than or equal to 10. So both conditions are met. So this is going to follow our normal distribution. All right, now you try your turn here. Go ahead and try this next one down at the bottom. Check with your partner and then come back. You can pause the video. All right, coming back, let's go to the back side of our paper here. And let's apply our normal distribution scores, z-scores, to the probability of random sampling. So we're going to take what we learned just now about finding standard deviation with the sample proportion and applying it to calculating the z-score. So we're calculating whether that value falls within what we want. So let's see. Polling organization asks a simple random sample of 1,500 first-year college students how far away from home how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles of home. Find the probability that the random sample of 1,500 students will give a result within 2 percentage points of the true value. This is going to tell us what scores we're looking for, right? Well, we have our n value is 1,500. And we have our p-value, which is 35%, right? So we want to find first the mean of the sampling distribution. Remember, the mean of the sampling distribution is equal to the population proportion. So it's 0.35. And then we want to calculate and interpret the standard deviation of the sampling distribution. So we're going to follow our formula here. Our mean is 0.35, and then we're going to do 0.35 times 1 minus 0.35 divided by our n value, which is 1,500. Calculate this guy. It's 0.012. Okay, so this is average distance from mean. So this is telling me that 35% on average, 35% live within 50 miles of their house. However, if I go up to, I would say if it's 35% on average, then that 68% is going to be within a little bit farther than that, or what is it? No, 35. So 35 minus 0.102, I'm very close to 35, right? Okay, so describe the shape of the distribution by checking the large counts condition. We'll do the same thing that we did. So we're going to do our sample size, which was 1,500 times our p-value, which is 0.35. We want that to be greater than or equal to 10. Let's see if this 525, yeah, for sure. So that checks out, that's our condition there. And then the 1,500 times 1 minus 0.35 or 0.65, has to be greater than or equal to 10. So we'll calculate that. $9.75. So both these conditions are met, meaning that this is an unbiased test, right? So calculate the z-scores for within 2 percentage points of the true value. So I'm asking how many what I'm asking is find the probability that the random sample of 1,500 students will give a result within 2 percentage points of the true value. So think if one standard deviation is 0.012 percentages from that middle 35, I want to know, like, between 33 and 35, what percentage of people are between those values. So we're going to use 33 and 37 because that's within 2 percentage points of 35, right? So we're going to use 0.33 and 0.37 as our X values. So we'll do 0.33 minus 0.35 because that was our mean, right? Divided by our standard deviation, which is 0.012. And then we'll go ahead and calculate that. All right, do our 0.37 minus 0.35 divided by 0.012. Positive. Nope. All right. So when I draw our graph here, we have 1 standard deviation, 2 standard deviations, 3, 1, or -1, -2, -3. So what I'm saying is I want to know the percent of students that fall between these two percentage values. So 1.67 would be like here. Positive 1.67 would be here. Get my highlighter from earlier today. So I want to know this between value, right? So if I'm calculating it in my calculator and I'm interpreting the probability, I'm going to go to my menu, 552, and my lower bound is my smaller z-score, so -1.67. And my upper bound is my larger z-score, 1.67. We don't need to put anything else in because we're writing it in z-scores. And here we go, 90.5%. Okay, so what is this telling us? What is this 90.5% telling us? It's telling us that if we continue to do samples of 1,500 students, that means that 90% of the time, their mean is going to be within 2 percentage points of 35%, right? Or of the 0.35. So 90% of the time, percentage points. Okay. You go ahead and pause the video and try the Now You Try Here, and I will shortly go ahead and give you the answers to those. So go ahead and pause the video, go do both you tries, and then come back. All right, here are the answers for the first page. You can check yourself. And then the answers for the back page here. Notice it says 86 or less, so you can disregard the and 94% there. So check your answers. All right, you do have a practice page that we'll check together on Friday, so good luck.